the representatives from SURPASS project, where Andrea Tumino and Ashwini Kumar Sharma will talk about the SURPASS project and fully recycled bio-based materials for building and railroads. So Andrea holds a PhD on physical chemistry, the characterization of soft materials using neutron and X-rays. Today, he works as a project and consortium manager at the Laboratory for Health and Environmental Measurements at CA CA expertise are broad and cover several fields, ranging from advanced material design and characterization, energy production and management, sustainability, and risk assessment, and many more. Ashwini Kumar is the R&D manager of IndraSmart, overseeing day-to-day R&D activities with a primary focus on developing bio-based polyethylene materials for energy efficiency, the construction, refrigerator, and automotive industries application. He has been involved in industrial R&D for over 5 years, with a strong interest of innovation and product development. So we welcome you both, and of course the floor is yours.
Well, thank you. I will start share my screen. Okay. I will not be able to see can you see my screen already?
Yes, we can. Yeah.
Perfect.
Excellent.
So first of all, thank you very much, Konstantinos, for this introduction, and also for organizing this third workshop that we had with the sister project. The first one was at the NanoSafe conference 1 year ago. Then we had a workshop on our SSBD methodology and approaches, how we develop this material last year, and now it's time to dig into the results from our case studies. This will be a tandem presentation. There will be Ashwin will present our case study 1, and I will then dig into case study 2. Before, let's give you an overview of what SURPASS is. So as you can see, we have three different case study. The first one is we use biosourced polyurethane resin with enhanced vitrimeric properties, and this is to replace PVC for window frames. The second one we use, again, based on the vitrimer technology, epoxy vitrimer, to replace metal and also non-recyclable resins that are already used in as strain parts. And the third one deals with the new technology, the multi-nanolayer technologies, to reduce or ideally have no compatibilizer for packaging technologies. We focus on case study 1 and case study 2 only, as they fit perfectly the scope of of this workshop. Developing the materials is not simply it's not simply the scope of the project. We actually aiming at finding new reprocessing technologies or adapting existing ones for the 3 case study, either by using vitrimerization of micronized polyurethane foam, or by mechanical and chemical recycling for case study 2. Last but not least, the goal of SURPASS is that of building a guidance tool that will be, and so all the data that we gather during the 42 months of the project will feed the digital infrastructure that will be accessible to European industry and innovators, but particularly SMEs. And this is because, as we have all seen diving into this project, the SSBD it's really it has a huge effect. It might have a huge effect on the cost of production. So having some guidance and some tools that people can have easy access and for free, that should at least boost the European new European plastic market for the future. Very few words on the consortium. We are 13 partners from 6 European countries. The consortium is highly complementary as we blend in research technology organization with RTOs, as you can see in the graph, university, but also big industrial partners and SMEs, as well as associations that such as the standardization body for Spain, UNE, and Waste Free Ocean, which is a non-profit organization based in Belgium. With this, I will now leave the floor to Ashwin that can give us more insights on case study 1. And Ashwin, just tell me when to change the slide and I will do it for you.
Okay, perfect. Thanks, Andrea. And firstly, I would take the opportunity to thank everybody for giving me an opportunity to present the work we are doing in SURPASS. So I'm Ashwini Kumar Sharma, and I'm working as I'm a R&D manager at Indusmat, and today I'm going to take you to the new recyclable by design biosource polyurethane, what we are doing regarding this in SURPASS project around next 5 to 7 minutes. So next slide, please. Yeah, so first, who we are and what are we doing in SURPASS? So to start with, Indusmat is a chemical startup which was founded in 2017 with a vision of redefining the buildings envelope with biopolyurethane material, which should be like energy efficient materials. And at Indusmat, we are involved in various innovation and R&D lines, right from material development to design a new product and making a use of technology and engineering to deliver the project which are required within the various projects which we are working on within Indusmat. So we have 2 offices. Firstly, our headquarters is based in Barcelona, Spain, and our international office is located in Netherlands in Limburg region. Next, please. Yeah. So to start with, it's necessary to understand the background. As you know, like climate change is a big problem. This is due to the evolution of various greenhouse gases into the atmosphere, especially CO2, because of which we are having a problem of global warming. And this all is because of the contribution of human activities, which we do because of to have a good life. And on further digging up this, you can realize that energy consumption is the main reason behind all of this. And you further, if you bifurcate, you can see space heating is one of the biggest contributor of energy consumption. So if you view the house using the thermogram, you can see the bad insulation is one of the reason why we consume a lot of energy. And this is the reason why we need a good insulation as far as the construction industry is concerned. Next, please. And this is also a well-known fact that from the various available material in the market, for example, cotton wool insulation or polyurethane foam or foam glass. Polyurethane material is one of the material which has a very low thermal conductivity with the value of around 0.020 watt per meter Kelvin. So, of course, it's one of the good material to work with, and already Indusmat has a good know-how on polyurethane material. However, polyurethane material also has some disadvantages, like they are fossil-based, and at the end of the life, you can recycle them, but with only the traditional methods of chemical recycling or mechanical recycling. However, chemical recycling and mechanical recyclings are not very effective way of recycling polyurethane because you need a big infrastructure. Moreover, it needs to be the raw material you generate from chemical recycling of this material is not 100% as good as the virgin chemicals. So with this, here IndusMed plays an important role in SURPASS project with the objective of developing bio-based polyurethane material to replace PVC as insulating material, with the main target of having bio-based and renewable raw materials in total development of the window frames. Moreover, to not compromise with the thermal performance and durability of the developed window. And the most important, to have 100% recyclability through vitremerization. So we are going to adopt a new way of recycling the material other than the traditional one already done in the market. So the goal is, yes, to develop bio-based polyurethane window frame and to have recycling at least 3 loops at the end of the life. Yes, next please. So here I represent you the total bio-based window manufacturing process from where we start. So as you can see, the starting point is the mushroom making. So at IndusMed, we made, of course, I'm not going to the detail of what we did, but yes, we developed a couple of formulations, I would say series of formulations with the bio-based polyols. And to start with, we always start with making some tests. For example, mushroom making test, where we can have we can compare the development of our formulation with the benchmark. And once you have a formulation which looks promising as far as compared to the gelling point, the foaming capacity, the foaming time, we move to the next step, which is making a plate sample. Once your formulation is okay and you make a plate, while making a plate, you can always do some thermal analysis of your material. And at any point, if you think that, okay, your material is not very good or is not very developed, you have all the possibility to go back and reformulate your formulation and again repeat the same process. Once you have a good results after making a plate, we generally make a small piece of window frame, window profile, which is 27 centimeters. Again, here we calculate all the processes. We see if everything is fine as far as processing is concerned. And if your formulation works fine and is everything good, then we move to make a 1 meter window frame profile, and respectively everything is fine, then we again make 3 meter window frame profile. This is all done through the kind of injection methodology. And as you can see, this is our first bio-based polyurethane window frame, which we developed here at IndusMed. Next one. Yeah, so here I represent you the benefits of having bio-based window frames rather than having fossil-based or with the PVC. Is the first one, the energy efficiency. It is more 66% more efficient than PVC. Durability is also good as compared to the PVC. It's around 40 to 50 years. Sustainable. It's also sustainable as we are using renewable content raw materials, and also within SURPASS, as we target to have to make it recyclable, at least 3 loops. So with all these things, the bio-based polyurethane foam for Windows application looks promising and is a promising as far as we have done whatever we have done till now. Next, please. Yeah, so here I represent you. So partially what we have done is already we have developed a window, and now here is the second half, which is the important aspect in the SURPASS is reprocessing of the developed window. So as you can see here, we have a bio-based polyurethane formulation, and within our consortium, our another partner, which is AUTH, which is also Technological Institute, is responsible of adding disulfide chemistry to the developed bio-based formulation, which will be used to make a window frame. And at the end of the life, the window frame will be micronized and will be reprocessed using the extrusion technique, taking the use of disulfide chemistry, where you can break the bonds and you can again have the bonds. So basically switching chemistry. And with this, this is one of our route, which is ongoing work. Next one, please. Okay. Similar to this, we have another route, which is also again done by one of our consortium partner at CEA. So here we have a different route where IndusMed is responsible of making the bio-based window frame, which again will be micronized at the end of the life, and using the Vitremer processing technique using a safe catalyst, which can be used in the micronized polyurethane, and again with the extrusion process will be recycled or reprocessed and make again a window, and this kind of loop will be repeated at least 3 times. Yes, so next one. So with this, actually, I come to the conclusion, because we, as I mentioned, we have partially achieved our goals, whereby we have developed a bio-based polyurethane formulation, which is around 90 to 100%, which is with the 90 to 100% renewable content. We have also developed our first prototype of our first bio-based window frame, which in total is around 65 to 75% bio-based content. We have also evaluated mechanical and thermal performance of our bio-based window. However, the reprocessing part is still going on, as I mentioned, with the LATAT and CA using disulfide chemistry or using the Whittimer chemistry. These are the work which are going on, and that's the reason I don't have much results on this to discuss. But yeah, so this is what we are doing in SURPASS, and yeah, that's all from my side. And I leave it to Andrea to continue. Thank you.
Thank you, Ashwin. And also, I want to, as a reminder to our participants, if you have any question, you can well reach directly to us. And I hope that anyway there will be time at the end of this presentation. I have to apologize because I mean, as Sofia before me, I'm not an expert in this particular field, but our expert from CDTech, one of our partners, could not attend today. So I will present the results from case study 2. As a reminder, case study 2 deals with the production of epoxy Vitrimer to be used to replace metals as train parts. These are several. There are several motivation to do so. First of all, it will be to increase the payload, and by reducing a lot the weight of trains, which finally and ultimately will translate also in a huge reduction in carbon footprint. However, this strategy of using polymeric materials to replace metal part is already exploited to some extent, and composite material are emerging in this field, which need to have particularly and strict requirement as concern fire, smoke, and toxicity. The drawback of using current technology is that those materials, as we have seen, they cannot be reprocessed, and so finally at the end these will be incinerated, or we will need to use very toxic and hazardous substances for the chemical treatment of what is left over. What cannot go finally cannot have these two routes, either goes to landfill or it is incinerated. So basically, SURPASS wants on the one end to replace metal for train structure, and at the same time anticipating the recyclability for composite material that are already being used nowadays. Starting from this, we managed to map the current situation and draft our safe and sustainable by design strategy. Here is another view of what we see in the slide before. Currently we either have metal parts or non-recyclable epoxy composite, which contain also harmful flame retardant and which contain hazardous flame retardant. What we aim to do in SURPASS is first of all that of using halogen-free flame retardant and recyclable epoxy matrix. This is again by using the Vitrimer approaches, having a lightweight and halogen-free composite material which will be suitable for structural part of for the railroad sector. railroad sector. And as we are at the moment, we have defined an open loop recycling strategies for to recycle our material for others application. I will give a few more words on this point at the end of the presentation, which will be shortly. So thanks to for producing this nice animation of how dynamic bonds in disulfide bonds work. So what we are using are the so-called 3R technology, epoxy resin made through vitrimerization, and also the family of non-halogenated flame retardant that we are using in our formulation. SURPASS is already at 2/3 of its life cycle, so we have managed to produce our first material with and without the fibers and the flame retardant, and we have characterized this. So basically, what we have from the first generation is what we have on the left of this slide. This composite scrap, they are first grinded into powder and then transferred into a mold. This is for what concerns the mechanical recycling route. Lastly, then we go to high pressure and temperature to form what is called the second generation flat composite material. This material here cannot be used. Already we know that cannot be used to produce the same part as before, and this is because at a lab scale, when we grind into powder, we end up cutting the fibers as well, so the mechanical properties will be compromised. However, we are still expecting data on this, but the toxicity and the fire retardant properties have been assessed and they are working very well. The second strategy is that of using chemical recycling approach. We have already some very interesting results with our epoxy vitrimer are swollen and dissolved in non-harmful solvent. There we have a list such as DMSO, gamma valerolactone, and so on. And this strategy, ultimately, the chemical recycling approach allow us to recover all the components. Yes, there are some loss at the moment, but there is some space for optimization, and we think that the chemical recycling routes, once scaled up, might allow us to have the closed recycling loop as we aim for. So at the moment, this is what we have obtained. So we are very happy to see that the SSBD strategy that we defined on the first year of the project worked very well and allow us to have already second generation material that can keep the same fire retardant property of the first generation material. We are looking forward to optimize our chemical recycling approach in order to recycle all components: the fiber, the vitrimer, as well as the flame retardant itself. And hopefully, if there will be another workshop, we aim to show you the final results of the project. For those who are interested, you can visit our website or scan the QR code to follow us on LinkedIn. And with this, our presentation is over, and thank you all for your attention.